In this video, I'm going to work through an example where I break down the determinant of a larger matrix. Let's remember the process that we use for calculating a determinant. So if we have a square matrix, we can choose any row or any column of that matrix, and for each entry in that row or column, we calculate the product of that entry and the corresponding cofactor for that entry. We get a bunch of numbers when we do that, and we add up those numbers, and that's the determinant of our matrix. And the key here, the way to make this be not as overwhelming, is to choose a row or a column that has as many zeros as possible. Okay, let's work through an example. So here we have a 4x4 matrix, and it does have a lot of zeros in it. And so if we're trying to find a row or a column that has lots of zeros in it, then there are a few good choices. For example, column 2 has 2 zeros. That's pretty good. Column 3 also has 2 zeros. Row 3 has 2 zeros. And those are really our best choices. So I'm going to kind of arbitrarily pick one of those, and I'm going to pick column 3 as my choice. So now what we do is we take each entry of that column and we multiply it by the corresponding cofactor. So the first entry is 0, which is in row 1, column 3. So we'll multiply that by the cofactor C1, 3. And then the next entry is 5, which is in row 2, column 3. So we'll multiply 5 times C2, 3. The next entry is another 0, multiplied by C3, and then finally we have a -4, which will multiply by C4. Now, the reason why we made a good choice here is because we don't have to actually figure out what C1, 3 is, because whatever that turns out to be, we're about to multiply it by 0. Same thing for C3, 3. So the benefit of having chosen a column here that has a couple of zeros in it is that it cuts down our workload. But we still have a couple of other cofactors to figure out, so how do we do that? Well, the formula that we have for a cofactor is that it's -1 raised to the power of the two subscripts added together. So if we're in row 2, column 3, we multiply by -1 to the 2 plus 3. And then we multiply that by the determinant of the matrix that we get by eliminating that row and that column from our matrix. So we have this 5 here, and if we eliminate that row and that column, what we're left with is a 3x3 matrix. And so we write down the numbers in that matrix, which are 1, -8, 3, -1, 0, 6, and 1, -2, 0. And then the other cofactor has a similar formula. So we're going to take that -4 and multiply it by -1 to the 4 plus 3, because we're in row 4, column 3. And that cofactor is the determinant of the 3x3 matrix we get by crossing out that row and that column. And that matrix is again a 3x3 matrix, and the entries of that matrix are 1, -8, 3, 2, 0, -2, and -1, 0, 6. All right, so now we have a couple of 3x3 determinants to figure out, and we're going to break this down in the same way. We're going to look in our matrices and try to find a row or a column that has as many zeros as possible. And I'm going to break this problem up into sort of two halves and add these two results together at the end. So let's focus on this left half. So again, we have a couple of good choices. We've got row 2, row 3, column 2, column 3. Those are all good choices. I'm going to, again, sort of arbitrarily here, just pick row 3. Again, that's not any better than any of those other good choices, but I have to pick one, so that's the one that I've decided to pick. So what we've got here is 5 times, this is -5, so that's actually -5 there. So -5 times that 3x3 determinant. So I've got 1 multiplied by the cofactor row 3, column 1, and then plus -2 times the cofactor row 3, column 2, and then plus 0 times the cofactor row 3, column 3. And again, I don't actually have to figure that one out because it's getting multiplied by 0. Okay, what's C3, 1 here? Well, what we get is 1 times -1 to the 3 plus 1 times the determinant of the 2x2 matrix that we get by eliminating row 3, and column 1 of that matrix. So there's row 3 and column 1, and so that matrix that we get, that 2x2 matrix, is -8, 3, 0, 6. And then this is going to be -2 multiplied by -1 to the 3 plus 2, multiplied by the determinant of what we get by eliminating row 3 and column 2. So that is going to be row 3 and column 2. If we eliminate those, then we're left with 1, 3, -1, 6. All right, now 2 by 2 matrices, we have a handy little formula to figure those out. So this first 2 by 2 determinant, we multiply -8 times 6, and then we subtract what we get, and we multiply 3 times 0. So -8 times 6 is -48. So what I have here is -5 multiplied by, this is 1 multiplied by -48, so I've just got -48. And then over here, I've got, that's -2 times -1, so that's +2. And then this 2 by 2 determinant is 1 times 6 minus 3 times -1. So that's 6 minus -3, which is 9. So inside those brackets, I have -5, and then -48 plus 18 is -30. So this half of my answer is 150. All right, so we're almost there. Now we've got another 3 by 3 determinant to figure out. And what you hopefully notice here is that if I choose column 2 has a couple of zeros in it, so this one won't be quite as bad. So we've got -4 times -1, so that's +4. And then in this 3 by 3 determinant, I've got -8 multiplied by the cofactor row 1, column 2, plus 0 times the cofactor row 2, column 2, plus 0 times the cofactor row 3, column 2. And that's two different cofactors that I don't have to worry about because they're getting multiplied by 0. So I've got 4 times -8, which is -32. And that next cofactor is -1 to the 1 plus 2, multiplied by a 2 by 2 determinant. And that 2 by 2 determinant is what we get when we cross out row 1 and column 2. So that's going to be 2 times -2, -1, and 6. That 2 by 2 determinant is going to be 2 times 6 minus -2 times -1. That's 12 minus 2, which is 10. So this is going to be -32 times -1 times +10, which is going to be 320. And so my final answer here is going to be this 150 plus this 320, and that's going to be 470. So that's the determinant of my matrix. So I would encourage you to go back through this video, follow all the steps, and then I would also encourage you to go back to this original 4x4 matrix and make a different initial choice. Our initial choice was to choose column 3 because it had a couple of zeros in it, but if instead you had chosen row 3 or column 2, you get a completely different solution process, but you should still end up with the same final answer of 470. So that's a great way to do a practice problem where you know what the answer is supposed to be at the end. So I hope this video is helpful, and have a great day.